Alright, so in this video I'm just going to do a quick refresher of graphing linear equations. And I know this is a fundamental Algebra 1 topic, but I just want to make sure we're all on the same page. So this should be a fairly quick video. Just want to quickly run through 3 linear equations and how we would graph them, okay? And I'm going to focus on graphing through slope-intercept form. And remember, slope-intercept form, if you don't remember, is y equals mx plus b, okay? And in this form, the value of m is going to represent our slope, okay? M is going to be an actual number, okay? It could be something like -3 or 1/2 or -4/5, okay? And b is going to represent our y-intercept, okay? So, for example, let's say we had an equation already given to us in slope-intercept form. So something like y is equal to -2/3 x plus 3. Okay. Now what this means, I already have it in slope-intercept form, and slope-intercept form just means I have y solved for on one side and everything else on the other side, okay? So what this equation here is giving us is that the slope is -2/3, okay? So what that means is I'm going down 2 and right 3, okay? So that's what that means. Going down 2, right 3, rise over run, okay? So down 2, right 3, and at the y-intercept is the 0.03, okay? So that's our y-intercept. Now when we're graphing from slope-intercept form, they're literally giving us a slope and a y-intercept. So we can go ahead and plot that y-intercept. 0,3 would be right here, okay? And now I can use a slope to find a bunch of other points, okay? So I'm going to go down 2 over 3. I'm going to go down 2 over 3. I'm going to go down another 2 and over 3. And I run out of room, but this would continue forever in that direction. And I can also go backwards from the y-intercept, okay? If I went down to right 3, to go the other way, I go up to left 3. So I can go backwards. So I can go up to left 3. I can go up to left 3 and up to left 3. So these can be a bunch of points that are on this line, okay? And with equations, it's equal to, so we just go ahead and we connect these points with a somewhat straight line. So this would be a pretty poor example of a straight line, but this could be the equation. This could be a rough sketch of this particular equation, okay? So notice how we're going down to right 3, down to right 3 as we go throughout this particular graph. So that is how we graph a line when it's already in slope-intercept form, okay? But a lot of the time, it's actually not going to be given to us in slope-intercept form. We're going to have to manipulate the equation to get it in slope-intercept form. So, for example, let's say we are given an equation, and let's say it is 2x plus y is equal to -4. Okay. So this equation is not in slope-intercept form. I want it in slope-intercept form. I want it in this form, y equals mx plus b, okay? So y is by itself. So what I need to do is I need to solve for y. I need to get y completely by itself on one side of the equation. And in this particular case, it's not too difficult to do that. If I look over here, all that I have to get rid of is this 2x right here. And in order to get rid of that 2x, I'm going to subtract 2x from each side. And when I get that, I'm going to get y is equal to, I can't combine -4 and -2x, they're not like terms, so it's just going to be a -2x minus 4, okay? And just like that, we are in slope-intercept form, okay? So I can determine what my slope is. My slope is -2. And for some people, they get kind of confused when it's just an integer like this. When it's a fraction, they find it a little bit easier because they go, okay, well, I'm going down 2, but how much am I going over? Anytime it's just an integer like this, you can imagine it over 1, because -2 divided by 1 is still -2. So I'm going down 2 and right 1. So that's our slope, down 2, right 1, okay? And our y-intercept in this case is 0, -4. Okay, so our slope is -2, and our y-intercept is 0, -4. Okay, so I can go ahead and plot that y-intercept as 0, -4, and now I can use my slope. I'm going down to right 1. So down to right 1, down to right 1, down to right 1. I keep doing that until I run out of room, and then I can also go backwards. I can go up to left 1, up to left 1, and I can just kind of keep doing this until I run out of room, and that pattern would continue forever. But I feel that's kind of enough points, right? We got 3 on each side of the y-intercept. That's plenty of points for us to get a good sketch of this particular line. So now all I'm going to do is I'm going to go ahead and I'm going to connect these points with a nice solid line and extend it in both directions. Okay, so that would be this particular graph. This graph here is the graph of 2x plus y is equal to -4. Okay, I just want to do one more, and then I'm going to kind of talk about what a graph really is, because a lot of times we're asked to create a graph for an equation, but I feel like a lot of people don't know what that graph actually represents. So I just want to do one more example. I'm going to kind of talk about what that really means. Okay, so let's say we had the equation. Let's go with 3x minus 2y is equal to, let's say -2. Okay, so this is our equation, and once again I want to get it in slope-intercept form. I want to get it in this slope-intercept form, y equals mx plus b. So I need to solve for y. So the first thing I should do is I should move that 3x over. So I'm going to subtract 3x from each side. So what this is going to end up getting me is -2y is equal to -3x minus 2. Remember, these are not like terms, so I cannot combine them. Okay, they're not like terms, so I can't combine them. So now almost there. I still have this -2 though. This -2 is multiplying y, so I can divide each side by -2, and I'm going to get y by itself. -2 divided by -2 is 1, so we get 1y is equal to -3 divided by -2 is +3/2, so +3/2 x. -2 divided by -2 is +1. So in this case, our slope is going to be 3/2, which means I'm going up 3 and right 2. Okay, that's my slope, and my y-intercept in this case is the point 0, 1. Okay, so I can go ahead and I can plot my y-intercept 0, 1, and I can use my slope up 3 right 2, up 3 right 2, up 3 right 2, and I can go backwards as well, down 3 left 2, down 3 left 2, and I'm just going to stop there, and I'm going to go ahead and connect this and make a nice line, a somewhat nice line. Not that great of a line, but whatever. This is a rough sketch of our line. Okay, so this is the graph. This is the graph of 3x minus 2y is equal to -2. Now, whenever we do this, I don't feel like a lot of people know what we're actually finding. What we're actually doing is we're creating a visual representation of every single solution for this equation, okay? Because there's actually going to be an infinite number of solutions for this equation, an infinite number of points that make this equation true. And all of those solutions are represented on this line. Every single point on this line is an ordered pair that would make this equation true. So for example, this particular point here that was on the line is 2, 4. If I plug in 2, 4 in for x and y, it's going to make this equation true. I'll go ahead and kind of just show you. So 3 times x, well, at that point, x is 2, minus 2 times y, and at that point, y is 4. And I should get this equal to -2, and if I do this, I'm going to get 6 minus 8 is equal to -2, and I get -2 is equal to -2. So that's a point that makes this equation true. Every single point on this line. I can do a different one as well. I can do the point -4 -5. Okay, I can plug in -4, -5. That's a point on this line, and it's going to make this equation true. So I would have 3 times x, which at that point is -4, minus 2 times y, which is -5. And that should get me -2. Well, I'm going to get -12 plus 10. -2 times -5 is +10. So plus 10 is equal to -2. And I once again get -2 is equal to -2. So that's what graphs really represent, okay, guys? So every single point on this line is a point that makes this equation true. That's what graphing really is all about, okay? So in our next video, I'm going to do a quick rehash of graphing linear inequalities, because I know that's also a fundamental Algebra 1 topic, but it is extremely crucial, especially once we get into systems of inequalities, okay? So I'm going to go ahead and make that video right now. When it's done, I'll post it. Make sure you check it out.